Hi everyone, welcome back to my YouTube channel. Today I would like us to look at a transformation. We'll be looking at transformations, and we're going to focus on a particular type of transformation, which is a reflection. We'll be looking at the reflection about the x-axis, about the y-axis, about the line y equal to x, about the line y equal to negative x. And talking about the transformation, a transformation simply involves changing. It can be an isometric transformation whereby it can change the position of an object without the size being affected. We have a reflection, we have a rotation, that the size is not affected. But we have an enlargement. In an enlargement, the size of the object is affected. Okay? So those are transformations, and we'll be looking at a reflection in particular. Now, when we have a reflection on the x-axis, the coordinate of a point change from xy to x negative y. Very important. When we have a reflection on the x-axis, the coordinate of a point changes from xy to x negative y. Okay, talking about a reflection, as I was saying, talking about a reflection on the line, on the x-axis. Since we are talking about reflection on the x-axis, we are using the points. Here we have 0, 1. If it's about this horizontal axis, you see that a point, if the point is here 1, 1, it has to change. It will change. If there is a point here, we call it a 1, 1. When reflected about the x-axis, it will change to 1, negative 1. You see that when there is a reflection about the x-axis, right, the y coordinate is that which is changing. That's why we say a point, the coordinate xy changes to x negative y. But if it's a reflection about the y-axis, which coordinate will change? If it's about the y-axis, okay, here we are using the unit vector. We are using 0, 1. We are using 1, 0, 0, 1, 0, negative 1, and 0, negative 1, 0 here. So if it is about the y-axis, we have the coordinate will change from negative x, xy will become negative xy. For example, if here is about the y-axis, look, 1, when you reflect, here it will be here. Okay, you see that it has changed. The y coordinate has changed. About the y-axis, the x coordinate has changed, sorry. So we have negative 1, 1. The y coordinate has changed. But if it is about the line y equal to x, if it's about the line y equal to x, for example, if you are to draw our line here, this is a line y equal to x, for example. Now for the line y is equal to x, it will simply be, the coordinate will change from xy to yx, which means like here, if you have here we have a coordinate on this line. Let's take a point on this line. We rotate any point on this line. Let's say, for example, here, no, this is the line y equal to x, is this line. Okay, let's have the line. Good. Now from this line, if we are to do a rotation, a reflection on the line y is equal to x, you see that the coordinates will simply change from xy to yx. But if it's on this other line, the line y equal to negative x, the coordinate will just change from xy to negative y, negative x, as you plot. And looking about the matrix, Apart from doing it practically, identifying these changes, we see that the matrix operator is 1 0 0 negative 1. Now for a reflection on the y-axis, the coordinate of a point changes from xy to negative xy, and that gives us the matrix operator negative 1 0 0 1 when you are talking about on the y-axis. Okay, you see that is the x component, because the main matrix that we're using here is the matrix 1 0. The matrix on the x-axis is 1 0 and 0 1 for the y-axis. The unit vector 1 0 0 1, 1 0 on the x-axis, 0 1 on the y. So if it changes from xy to negative x comma y on the y-axis, it means the x coordinate has changed. That is why instead of 1 0 now is negative 1 and 0. Now for a reflection on the line y equal to x, the coordinate of a point changes from xy to yx. It's simply an interchange. It means if you reflect 2 3 on the line y equal to x, it will simply be 3 2, and the matrix operator 0 1 1 0. You see that change from our vector, our operator 1 0 is now being changed to 0 1, 0 1 being changed to 1 0, because that's a reference matrix operator with the unit vectors. Now for the reflection on the line y is equal to negative x, the coordinate of a point changes from xy to negative y negative x, xy to negative y negative x. You see the interchange. There is an interchange and a change of sign, which means if you have the point 2 3, it will instead be negative 3 negative 2 that you will plot. And for that reason, the matrix operator, there will be an interchange. Instead of 1 0, it is 0 negative 1. Instead of 0 1 for the vertical column is negative 1 0. Those are the 4 matrix operators for these reflections. So we'll go straight to solve some examples. Okay, example 1. Consider a triangle A, B and C. Reflect the triangle ABC on the x-axis. Okay, to reflect on the x-axis, we have the matrix operator that we can use. The matrix operator on the x-axis, as we have seen how to derive them, is 1 0 0 negative 1. Then we bring out the matrix. This is 2 1. We write in column form 2 1 6 1 4 4. Now we know that multiplying a matrix, we take the row, we multiply by each of these columns. This row here, multiply 1 times 2 is 2 plus 0 times 1, we have 2. 1 times 6 is 6 plus 0 times 1, so we have 6. 1 times 4 here, 4. We have 0 times 2, 0 plus negative 1 times 1, we have negative 1 here. Negative 1 times 1 here, negative 1. Negative 1 times 4, negative 4. Okay. So if you are using apart from multiplying like this, this is what we can do. As we said, when it's a reflection on the x-axis, the coordinate will simply change because it's about the x-axis. The y-coordinate changes. So the coordinate xy goes to x negative y, which means 2 for example, 2 1, okay, will be negative 2 1 here. If you are to reflect, it will be 2 negative 1. If you are to reflect B, it will just be 6 negative 1. If you are to reflect C, it will just be 4 negative 4, using that other approach. Now let's look at it graphically on our graph, how to do this reflection, because you can be asked to plot this on your graph. Okay, this is our y-axis, this is our x-axis. We are given the points A 2 1. This is how we plot 2 1. B 6 1. C 4 4 4 4. Okay, so we link our triangle, we link we link our triangle, which gives us 2 1. Linking our triangle, we have these points. Okay, so if we are to produce our triangle, we have 2 1. This is 2 1. Then we have here 6 6 1, and we have the next coordinate here 4. This is 4. We'll move to is 4 4. So we'll complete our triangle. That's our triangle here, 4 4. Now, having observed that on the x-axis the reflection moves from a point will move from xy to negative xy. It means this point 2 means this point 2 1 will move to 2 negative 1 where reflected on the x-axis, and the point 6 1 move to 6 negative 1, and the point 4 move to 4 negative 1, which will link our triangle. That's the reflection. You see that the reflection about on the x-axis, you see that it is the y component that is changing. It's moving, it's on the x-axis, the y component has changed from the positive 1 to the negative. That is what changes. Okay, we coordinate, see the same triangle 2 2 1 6 1 and 4 4. Reflect the triangle on the y-axis. On the y-axis, if we want to do it without a matrix operator, it means we know what I said on the y-axis. On the y-axis, which coordinate will change? About the y-axis is the x coordinate that will be negative. So this will simply be negative 2. When you reflect it, it will simply be, the triangle will now become negative 2 1, negative 6 1, and negative 4 1. Now, if you are using our matrix operator, when we multiply, we are going to have negative 2 1, negative 6 1, negative 4 4. As simple as that. Take note that you take the row, you multiply by the column. Now, let's have a look at the graph, how it can be displayed there. Okay, we are reflecting about the y-axis on the line. The y-axis is the line. You can also say the line x is equal to 0. So we see that the point is changing from, we say 2 1. If it's on the y-axis, 2 1 will change from, it will be negative 2 1. So we are going to have negative 2. The x coordinate is what is changing on the y-axis here. So we have negative 2 1. We have negative 6 1, and we have negative 4 4. Negative 4 goes to 4. I will connect our triangle. This is what is produced. This same triangle now ABC, when reflected about on the y-axis, which is the which is here, we see that it gives us this reflection on the y-axis. Take note that on the y-axis is the line x is equal to 0, and on the x-axis the line y equals to 0. Okay, let's go to the third example. So on this line, the coordinate is simply changing from xy to ys. It means if I'm reflecting 2 1, 2 1 will just be on the line y equals 0, will just be 1 2. 6 1 will simply be 1 6. 4 4, since they are the same, will be 4 4. Now, if you want to use our matrix operator, let's see what you see. It's still just an interchange of the coordinate 1 2 1 6 4 4. Okay, let's display that graphically. So 2 1 becomes, the point 2 1 becomes 1 2. If it is on the line y is equal to x, this point, let's reflect it on the line ABC on the line y equal to x. So 2 1 is 1 2 1 2, and 6 1 becomes 1 6, and 4 4, yes, it's still maintained as 4 4 4. That's our 4 4. You see that this is our line. This is the line. The line y is equal to x passes here towards the origin. So there is a reflection on the line y is equal to x. If you have this line here, it will give us, if you are to form our line here about not passing through this point, you will see that we are going to have good, this is the line y is equal to x. Okay, you see that our reflection about that line y is equal to x, this point has now been carried to this. See the way it has been reflected about that line. Okay, let's go to the fourth example. Now this